Hello, welcome to the AP Calculus Area Review video by Ben Hatch and Zephram Bowler. First, we're going to start off with going over a few key points that you need to understand for doing these problems. So the first one is that if you multiply by -1, it switches the interval, and it actually starts to make sense, so it's going left to right, 8 to 10. And the second point that we would like to point out is that if you have an interval from 0 to 10, you can also split it into two different ones from 0 to 4 and 4 to 10. And it ends up being the exact same answer. And the last and final point is that if you have area underneath a curve, as in right here, then you would just subtract it and it becomes negative. So it would be 9 pi minus 12.5. Okay, so now we're going to start with our first problem.
Here we have a definite integral from x equals 1 to x equals 6, and as you can tell there's an absolute value problem in the middle, and it's the absolute value of x minus 4. Now to start this problem you're just going to want to graph x minus 4, well the absolute value of that, and we'll go from there. So I'm going to go ahead and graph it. So to graph this absolute value you're going to want to go over 4 and have your point, and it's bounded by x equals 1 and x equals 6, so you can go ahead and draw that. And then you're just going to want to go up 1 and over 1 in both directions and draw your lines. And then you want to find the side lengths of each triangle, so we have 2 and 2 and 3 and 3. And you're going to want to find the area underneath the curve, which is just the area of each triangle. So the area of this triangle is 2, and the area of this triangle is 4.5, which is base times height divided by 2. And then you're going to add them together. So it's pretty simple. You have 4.5 plus 2, which equals 6.5. And that is how you find the area underneath the curve of this problem using a graph.
Okay, here we have another definite integral problem, and I know this one might look terrifying, but I have good news for you. It's actually really easy. If we look at the integral, they start and end at the same number, which means that there's no change in x, so there's actually no area, so the area is equal to 0.
Here we have yet another definite integral, yet this one, there's something different about this one. And as you can see, the bounds go from 4 to 1, which doesn't even make sense. It has to go from left to right. So as we talked about earlier, to do this, all you have to do is multiply by -1, and that switches the bounds. So you get 1 to 4 of 2x plus 3. And for this one, we're also going to want to graph it out. Well, there's two ways to do this problem. You can either graph it out or you can do it mathematically. And first we're going to show you how to graph it. So as you can see, this is a simple linear graph. So you find x equals 0, where the y value is 3. And you're going to go up to over 1, over and over and over again, and draw your line. So the bounds on this one are x equals 1 and x equals 4. So right here. The height of the trapezoid and the two bases, which is 5 and 11. And as you probably know, the area of a trapezoid is height times base 1 plus base 2, all divided by 2. So in this case, the height is 3, base 1 is 5, base 2 is 11, and you divide by 2. So you have 3 times 16, all divided by 2, which is equal to 24. And there you have it, graphically the area of this integral.
Okay, now we're going to do this problem mathematically. I already flipped the integral by multiplying by -1. And now we need to find the antiderivative of the equation, which is x squared plus 3x. And now we need to plug in the 4 first, and take away the same equation by plugging in the 1. And now we just go ahead and do the math. And now if we simplify it, we'll get 24, which is equal to our work by graphing it.
So number 7 is an area between the curves problem. And I would first like to just point out that when you are doing with respect to x, it's going to be left to right of top equation minus the bottom equation of dx. And when you're doing with respect to y, it's going to be bottom to the top of the right minus the left. So just remember this throughout all of these problems, these last 4 that you're going to do on the worksheet. And let's get started on number 7. So what I have drawn right here is what your calculator is going to look like. Sometimes I like to draw a sketch so I can see it for myself and have my own points. And you're going to find the point of intersections on your calculator and store them as A and B. And after you have done that, it's fairly simple. All you have to do is have the integral from A to B, left to right, of the top equation minus the bottom equation of d of x dx. And you should get 10.3371. And that sums up all of the problems that you need to know to be able to find area underneath a curve and between 2 curves. So thank you for watching, and please try our review worksheet and check it with the key to make sure that you have everything memorized and you're ready to go for the test. Thank you for watching. Bye.